Okay, so in this video, we're going to look at the inverse normal distribution. So we're going to try to calculate the value of a variable when I've been given a probability. Now this one is going to assume use of the TI. We can do it by hand if we follow the 68, 95, 99.7 rule. For very special cases, that's a different video. So this one, we're going to need our TI or other CAD software. The one I'm using is TI to help us to find the values of variables. So for example, I'm given the question, find the value of C when the probability of being less than C is 0.3912. Now, essentially what we have to do, remember, the normal distribution is a graph, area below is 1. Area below is 1 because all probabilities add up to 1. So you're integrating. So to find the value of the variable, essentially what we have to do is when we're drawing a bell curve, there's some value, maybe C is there. I know that area is 0.3912. So I have to find the integral from down this end up to C of the function and put it equal to 0.3912 and then solve for C. That's nasty because remember, the function is not nice. Remember, the function is this. Don't know about you, but I do not want to be trying to integrate that because you guys can't. And then even if you could integrate it, then you've got to deal with it having a value of C in there and try to solve for C, get C by itself. That's nasty. Let's not do it. Let's use the inbuilt function on the TI, which is the inv-norm option, and you're going to get that through the menu, probability, distributions, and then inverse normal, which I'll show you in a minute. So let's have a go. Let X be normally distributed with a mean of 27 and a variance of 9. So let's do this. So X is normally distributed with a mean of 27 and a variance of 9. Now I can write 9, but if I can, it's also a good idea to write 3 squared for 9, because remember that is sigma squared, and I want sigma for all my entries, and there's mu there. Now, just like in the previous video, I'm going to suggest you should always draw a bell curve before you get working on this sort of stuff, because it gives you an indication of what you're working with. So here's my bell curve. It doesn't have to be perfect. It's not getting marked anyway. I'm going to mark in the mean. The mean can be there. So again, I know above the mean is half, below the mean is half. And then I'm going to mark in the variable I'm looking at. So the probability of X being less than C, so to the left, is 0.3912. So I know everything to the left there is a half. So it must be a bit further along here somewhere. The value C there. So all that area in there is going to be 0.3912. So the way I do that is I use the inv-norm option on my calculator. Now, the A in this option here, that is area under the function, but it's to the left of the variable. In this case, we're dealing with less than, so that is okay. It's when we get the next question, we're dealing with bigger than. It's not so good, but we'll get to that in a minute. So the area to the left of the variable is what we put in here. So in our case, it's 0.3912. Mu is 27 and standard deviation is 3. You enter that in your calculator, press enter, and you're going to get your result, which should be less than 27. So let's give that a go. So menu, probability number 5, distribution is number 5, inverse normal number 3. Area to the left of your variable was 0.3912. Mean was 27, standard deviation was 3. We press enter, and it gives us 26.171. I've rounded off the 3 there. That is less than the mean, which was 27. So it's a reasonable answer. If we had got a number bigger than the mean, we got an issue. All right, so the next one. Again, we're going to draw a bell curve. I should have just copied and pasted that one, but I forgot. There we go. We're going to mark in our mean at 27 here. Before I forget, I will copy and paste it for our last couple examples. For use there. Now let's mark in the variable we're after. Bigger than C is 0.7218. Well, bigger than, so if I put a value there, it's bigger up here. Except the probability is 0.7218. If I draw a line there and up, that's all 0.5. So it must be sitting down here somewhere. I don't know the exact value, it's the general area. So now I'm going to find the value of C. Again, my input is going to be the inverse normal. Now I want the area left. I need this area in here. So I should do it from there. That area comes in there. And that's going to be 1 minus 0.7218 because it's complementary. It's either bigger or not. That's going to go in there. And that gives me 0.2782. The mean is 27. Standard deviation is 3. We're going to put those values in and see what the value of C is. I said that was 0.2782. And that gives you 25.235. As the variable value there. Again, it makes sense. Our diagram suggests that it should be less than 27. It is less than 27. That's what we want. Last one. This last one's a little on the trickier side, but it's still very manageable if you draw a diagram carefully and you think carefully what's happening with the areas. So we want to find the value of C so that this is true. Well, let's draw values in again. So C, so we got the value of 22 there. And we're going up to C. Now, exactly how far up, we don't really know. But we know the probability is 0.415. So it's going to be either just this side or just that side, because remember, this whole section here is 0.5. And we've removed a chunk from there. It's not a massive chunk we've removed, but we removed some. So it's going to be fairly close to the mean. Let's draw it just above here. We don't know entirely for sure. I'm going to do this. Problem with this scenario, though, is that remember our calculator only takes the area to the left of a coordinate, the left of a variable. So I need all of this in here to find C, but I've only got this much here. This much in here is the 0.4512. So I actually didn't know what this one is as well, so I know all the area left. And this is where we start using a bit of our symmetry with, not so much symmetry, but properties of normal distribution. Now this thing here is going to be the same as the probability of being less than C, which would be all, of course my pens are not working, less than C would be all of this and you can hopefully see that if I then subtract less than 22, you're left with this blue section in here that I wanted between 22 and C. So what that means is I can rewrite this thing as being less than C minus being less than 22, and together they give you 0.4512 like that. And it's a matter of now solving to get the probability of X being less than C by itself. And that's 0.4512 plus the probability of being less than 22. I have enough information to calculate this. That's going to be using our norm CDF function because I have the variable value. I know the mean, I know the standard deviation. So let's do that quickly. We're going to put this in our calculator. Remember our norm CDF, so that was menu 5, 5, 2. The lower value is going to be negative infinity. The upper value was 22. That's the value we're going up to. 27 and 3. And that gives you 0.04779. 0.04779. So let's add those two together. So let's add that to 0.4512 and we get an area of 0.4989. 9. That's the probability of getting less than C. So if you look at that, that's pretty much bang on 0.5. So C must be right on 27. But what we now do is use the inverse normal option. So this here tells me all the yellow area that we had before. All the yellow area. And that's what I want. So we use our inv norm. We put the 0.49899 in there. We put our mean of 27 and our standard deviation of 3. And then you'll find from that, let's put in here, value. Remember that what we do to insert is push up once, press enter, it brings it back down where the cursor was, press enter, and it gives you 26.992, which is very close to what 27 was, and that looks pretty reasonable in that case. And that's how you use the normal distribution and your TI to calculate the value of a variable when you have probabilities given.